Okay, we got to record now, so we got to be legit now, okay? So everybody put on your board faces. Let's pull up the handy dandy questions. See if we got any questions to go into before we move on. Are we in chapter 2 yet, or we finished chapter 2? Good. We can get into the math after we go over these questions. Good golly, there's 3. And then 1.3, 1.5, and one of those stupid emails. If you get an email about attendance, just delete it. You know, nowadays, you got to have a job. You got to have a reason to have a job. Okay, so that's what the definition of bureaucracy is. It's, you know, paperwork involved to give me a reason to have a job. So you got somebody over there in the library or wherever, Ruby Hicks, that sends out these emails or directs these emails because of the attendance that we have to take, because we don't want to we want to keep people from milking the system. The 1% of 1% to milk the system of financial aid. We're talking about 0.01% of the students. So we got to crack down on them people. So we got to take mandatory attendance so we can give that person in the library a job. Y'all get it? You'll see one of these days when you get into your careers and you got that guy over in the corner that has a job and you don't know what he does or what she does. That's why. All right, so 1.3, number 7. Number 7 in the book, number 3 online. Number 7 in the book, number 3 online. First of all, is it a test question? No. Is it a homework question that you have to do? Yeah, we've already done it. I'm going to, sample space. We've already done this one, but I'm going to start you off. It says 6-9. Well, you got to click on the table. So make sure you click on the table. Well, and remember, some of these are coming from, what the heck?
No, just the blue button.
Oh, thank you. Yeah, heaven forbid make the whole thing a link, Okay, there's your courses right there. And I'm just going to start you off. Now, the way that I do these, and remember, some of these are night class students too. They're my night 120. So I take the first one, and I put it with all of them. So how many? It says comment on the likelihood that if you, okay, all 3, right?
Mm-hmm. Well, that's part of it.
Oh, okay, I'm sorry. All right, so 3 course selection. So how do we do this? Give me one instance. 697, what? 665 and what? 662. Okay, and then I would take the first 2 and I would put it with what? 635. So 697, 665. I think the last one we did was what, with 2?
Yeah.
Okay, so, and 635. And now I've got these 2 taken care of. Now I do it with this one. 697, 665, oops, and 619. Now, at that point, I'm done with the first 2 being lead. So what's the second thing I can do? Erase this one right here and drop it down to what? This one. So I'm going to erase that one. And I'm going to drop it to this one. And I'm going to go 697, 662. And somebody give me what's the third one going to be? Enunciate and volume, please.
635.
665. Even though I think you said 635. 697. I'm going to put a dot there. 662 and what? 635. And then 619, or 619 down here. And then 697, 662. Now what am I going to do? Take my handy dandy virtual eraser, and I'm going to erase these. And now what am I going to do? Put one beside what? I did 697, 662. I did this. Now what? Put it right there. Everybody see the pattern? And that's how you do these. Okay, so I'm going to finish the third one. So that's going to be 697. I'll just do 697, 697, 697. And then the second number is going to be 635, 635, 635, 635. And what's the first number going to be? 665. And then the second one's going to be 662. And then the third one's going to be 619. And then you're going to put one right here. So how many more are you going to have? You're going to have four, what, 3 more? So you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to be 12 in all. Capiche? And then it says, comment on the likelihood that 697, 665, 697, 665, and 635. Is that it right there? And then there'll be another one somewhere. There'll be like 4, won't there? 4 out of 12 is what? 1/3? So it should be 1/3. But that's how you do it. Okay? And I don't want to go into it too much because we got a lot of people that's going, oh yeah, I invented it. Okay? And then you got some people that's like, I don't know how to do it. So I got to find the happy medium between the two. Because we got to get to chapter 3 because that's where we do all the math and 80% of your test. All right? So that takes care of that. And you feel good about yourself. So you don't have to carry around that gallon of water. Just use a water bottle like everybody else. Next, 1.5. I don't think we've had any questions out of 1.5 yet. 1.5, number 1 in the book, number 1 online. What is a closed question? This is not a test question. This is a closed question. What is an open question? Discuss the advantages. Okay. An open question. Okay. An open question would be like, okay, a closed question would be, who are the 2 teams that are playing blah, 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 blah. Okay. Why is that a closed question? Because there's only 2 teams. All right, that you know of. Let's say, okay, who are the 2 teams that are going to be who are going to play in the football game for Anderson County bragging rights? Who is that? Hannah and Westside. It's a closed question. Why? There's only 2 in the Anderson, not Anderson County, but in the inner city, in the Anderson right here. That the rival. Who is BHP's rival? Isn't it Palmetto?
Yeah.
Palmetto. Okay. Who is Crescent's rival? Is it Pendleton?
I think it's Pendleton.
Okay. All right. So you got a closed question. How many people are in this class? That's a closed question. All you got to do is count it. You got to hit the roster. What's an open question? Anything that pretty much is subjective. Okay. Who is the best football player in the United States? Is that closed or open? It's open. Why? Because everybody's got an opinion. Okay? That's the difference between an open question and a closed question. What do you not want on a survey? Open. You don't want subjective questions on a survey or a poll. You want closed questions. But you don't want to lead. You don't want to say, the blank blank party is the worst party. Do you believe in the party? That's a leading question. So you got leading questions and non-leading questions. You want to be neutral. And you also want to keep it closed because it's easier to count closed questions versus open questions. Okay? That's the difference. Now, I don't know what the Philadelphia lawyers wrote down, for an answer, but that's the definition between a closed question and open question. Non-subjective and subjective. Capiche? A closed question has fixed choices. Who are the 2 teams for Anderson County? Blah, blah, blah. Hannah and Westside. It's closed. Boom. It's over with. So that's the answer. If it's not in the book, that's not unusual. Okay? So that's a good question to send me. Whoever sent it, whether it's morning or night class, whichever. 2.1, 13/6. I have no clue. A national survey asked people how often do you eat out, blah, 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 the frequencies. Make sure you say it like that, frequencies. Or blah, 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 blah. Okay, I'm only going to do the important thing. I don't, if it's going to ask 15 letters, I'm not going to ask that on a test. But the thing I want here is the relative frequency and the cumulative frequency. Also, the cumulative frequency does not mean a that blame thing. All right? The relative frequency is a 25-cent word for what? Percentage. So do that right quick. First, you got to have what? The total. So go ahead and add those up. I'm going to do it in a spreadsheet.
I think it's 2,079.
Because I want y'all to think that I want y'all to use Excel so you can complain to my department head that I want you to master Excel. That's what I want to do. Although I went through and told y'all 15 times I don't want it. I just do it so I can present it on the screen. But y'all don't listen, so I have to do that. Actually, she thought it was a good idea when I started using it back in dang old 1998. Oh, I'm sorry. Not here at Tri-County, but.
So you want us to download Excel?
Yep, I want you to master it too. All right, so there's so I take my handy dandy summation key, dang old sigma, capital sigma, dang old enter. There's your dang old total. Put total out here so you know what it is. Now we need to do our relative frequency. Dang old percentage. And that's equal to, for those that are not talking while I'm talking, divided by, well, no, be this one, divided by that number, and F4. For those that know what F4 does, it locks it, because when you copy down, it'll copy this one, and it'll say error, and it'll copy this one, because you can't divide by what? 0. And that's nothing there is assumed to be 0. So you have to lock this number in, so when you copy down, it doesn't copy these zeros right here. I got to tell you that because I want you to master it. That's a joke. All right?
I remember on this question, you can't put in percentages though.
Yeah, they wanted as, and the next question will ask you for percentages. So you have to read the directions, okay? And if you ask for percentages, you just dang old hit the dang old, I don't know where it is. There it is. It hides from you sometime. There it is. Capiche? Now, what about the cumulative frequency, which means nothing? You write this one down. So I hit equals, and I put that. And then down here, I hit equals that number plus what? The next number. And then I copy that down, and the last number should equal, no yawning in class. The last number should equal what? Yep, those two should equal each other. And I tell people it's a way to check to make sure you didn't screw up the total, because that's the only mathematical. I don't know what the cumulative frequency is supposed to do. So there you go. That is a test question, probably 2 test questions on the test. So make sure you know how to do it. Okay? And that's all I ask for. I don't ask A through F and Z. I don't do all that. Okay? All right. So now let's go to the handy dandy book. And let's look at, well, no, let's don't. Let's do this. I'm going to do this because it will be easier for me to get everything into one. So make sure you take good notes. All right? Make sure you take good notes, especially those people that invented the books, okay? Y'all invented statistics. So even though you think you know everything, you better write some notes down, okay? I'm not going to say it again. Get your notebooks out and your pencils. Okay? Even though you invented the book, get them out. Well, I don't want that. All right, I'm going to give you 5 numbers. Now, let's make it 8 numbers. 9. Let's do 8. So I'm going to give you test scores. 25. No, not 25. You're not that dumb. Let's go with 75. 95. No. 85. 85. 87. 90. 92. 93. 95. and 99. That's 1, 2, 3, 4, 5, 6, 7, 8. All right? And I want you to go over here. I'll go ahead and let those people that know everything do it. Mean, and you don't use a calculator. Median, mode, range, mid-range, variance, and standard deviation. Go ahead and fill out those 4 or 5 things. I'll make it bigger where you can see the numbers. Now, I'm expecting probably half the class to know what to do and half the class not know what to do. Remember, the whole point of you being in the class is to learn something, because if you knew everything, you wouldn't what? You wouldn't be in the class. There you go. Is that big enough? There you go. Now, a lot of these are pretty simple. Now, you can use your calculator to add those up. You can do that. But I don't want your calculator to do everything for you, because then you're not thinking. If you're not thinking, and if you do enough not thinking, what happens when you don't walk for 8 or 9 months? You try to get up, what's going to happen? You're going to fall down. Okay? If you don't use your brain to think, what's going to happen? You actually say, well, you're not going to be able to think. And a lot of people say, well, that can't happen. Go out in the real world. You'll see people that can't spell mom backwards.
I said that to my mom the other day. She thought it was weird.
So add these up. But that's all I want you to do on your calculator, because I know y'all, some of y'all can twirl that thing around on your calculator on your finger like a damn basketball. You're on the calculator drill team at high school. Okay? Now what I'm doing is I'm getting probably 3.1, 3.2, and 3.3 all together today. Okay, so you should be being able to do several questions in homework on 3.1, 3.2, and 3.3. Now I will show you how to do it on Excel, which I'm showing you now, and I will show you how to do it on your calculator once we get the mechanics out of the way on how to find it by hand. Somebody tell me how to find the average. You've been doing it since what? 6th grade. How do you find your test average? No sneezing in class. How do you do it?
Take the total and divide by the amount.
Okay, you add them all up. So we go over here, take our handy dandy summation key, add up all these, and divide by what? How many? Divide by 8. Everybody should have 89.5. Now, what is the median? Well, we're going to do this right here because I want to spread this out. Somebody give me the rule on medians. What's the rule?
Number in the middle.
Huh?
If you put you have to line them up in numerical order, and it's the number in the middle.
Okay, that's one of the rules. What's the other rule?
Even number, you line up in the middle.
Exactly. There's 2 rules. There's even and odd. I'm going to say if n is equal to odd, you just find the what? Find the middle. But if n is what? If n is even, you got to average 2 middle numbers. If n equals even, you got to average 2 middle numbers. Make sure you write that down. Now, why am I going over this? Because there are some people that haven't had probability and statistics and they didn't know that. May be in the minority, but make sure you know it. So I've got to take these two numbers right there, and I'm going to take them and I'm going to highlight them, and I'm going to go over here, no yawning in class, equals, parentheses, I'm going to take that number, plus, now I do realize, you know, I got 3 degrees or 4 degrees, working on 4 degrees, so I ain't never going to get that fourth one though. Anyway, don't want it. All right, the two right there, I've got several degrees, and I know the average between 90 and 92. Why are you calculating it, Hubert? Well, what if I ask you to take it to the 10,000th of decimal place? None of y'all will do it because none of y'all are Rain Man, okay? And if you take it to the 10,000th decimal place, you're going to have to either do it on an Excel spreadsheet or do it by hand with a paper and pencil or do it on a calculator. So I know the average between 90 and 92. I have to go through this because there's always some smart ass in the group that goes, well, why don't you just take 90 and 92 in your head and divide it by 2? Okay? Not always are you going to be given 2 simple A numbers. Okay? Not all the time, are you? So you got to know the mechanics behind doing it. You add them up and divide by 2. So there you go. All right, now what? The mode. Mode is useless. I don't really care about it, but they're going to ask for it. Mode means what? Most. M-O-D-E equals M-O-S-T. M-O, M-O, mode, most. The one that shows up the most. Can you have more than one mode? Yes, that's called polymodal. The mode really doesn't mean anything until later on in statistics, okay? So it's not that big a deal. But can you have 3 modes? Yes, that's trimodal. Can you have 2 modes? Yes, that's bimodal. Okay, one mode is monomodal. And then after 3, it's called polymodal. But it's the one that shows up the most. If you got 2 90s, and that's the one that's 90. If you got 2 90s and 2 89s, then they show up the most. That's 89, 90. Okay, it can be 2 or 3. Do not put 0 if there is none. Why should you not put 0? Because some smart aleck teacher is going to mark that wrong because you put 0, and they're going to say 0 is not even in the data set. Okay, so make sure you put none. Put does not exist. There ain't none. Make sure you put something that says there ain't none or there isn't any. Okay, you make sure you put it. Do not put 0. Meaning there's none. Don't do that. Because like I say, there's those smart aleck teachers out there. So here, I don't know, is there any? I don't think there is. So I'm going to put nairn. Okay? Range. What is the range?
The biggest and smallest.
Highest minus the what? Smallest. Yeah, just highest minus the lowest. Simple as that. What is the mid-range? I'm waiting. That's not rhetorical.
Q3 minus Q1.
Huh? Just tell me what it is.
Your upper quartile minus your lower quartile.
How do you get it? Tell me the mechanics. Tell me how you get it. Take 2 numbers and tell me how to get it.
So like, I just did my Q3 minus my Q1.
I don't know what you're talking about. It's the highest plus the lowest divided by what? 2. Highest plus the lowest. I know what you're talking about. I just wanted to make you feel insecure and, you know, eventually quit. All right, highest plus the lowest divided by what? 2. It's also called, in algebra, the midpoint. Midpoint, mid-range, doesn't matter. It's the same thing. Highest plus the lowest divided by 2. Now, I could tell by the overabundance of feedback when I asked that question that y'all knew the material. Okay? Highest plus the lowest divided by 2. Now what? The variance. How you get the variance? A whole buttload of calculations. Okay? I'm going to show you how to do that. Anybody got questions on what we've done so far? So the mid-range is going to be equal to, parentheses, the highest plus the lowest divided by 2. And everybody should have that number. Now, what is the variance? Well, I'm fixing to write down the variance formula for you. Now, the reason I write it down before we start is I want you to read the variance problem, the variance formula. Variance is equal to the summation of x minus x bar, quantity squared, divided by n minus 1. So what do we got to do? Read the formula. What do we got to do? What is x bar? X bar is the average, right? So write that down. X bar equals average. It's the sample average because it's a regular letter. What if it was mu? X minus mu over n minus 1. That would be the population. Okay, it's not the population, this is the sample. Sorry. So make sure you subtract the mean from each one of those numbers. Y'all supposed to go into cardiac arrest.
I'll drink that.
Huh?
I'll drink that.
Okay. So what do? X is right here. So this is going to be a column called x minus x bar. Of course, y'all know how to do this, right? Y'all invented it. So do it. Each one of those columns, each one of those, take x bar away from x. Some are going to be negative, some are going to be positive. If you can't do it, that means you're just what? A disappointment, a failure at life, and you probably need to quit. Yes, I actually had a student complain that I told them to quit school. People need a freaking sense of humor. They need to, you know what they need to do in high school? They need to offer classes in having a sense of humor. Would probably be too difficult. Probably people would fail. Much better to have study hall or whatever it's called now. Secrets to success or strategies to success. That's a dumbass class. They need to offer dadgum taxes, savings, accounts, and interest, so you know what to do when you get out of school. Oh no, they want to keep you stupid. So it's easier to control. Oh, shut up, Hubert. 75 minus what? 75 minus 89.5, hit F4, and copy that down. Now, y'all's numbers need to look like my numbers. And you should feel good about yourself. Dang old 851, dang old 26 degrees. We're all going to die. Can y'all imagine how nasty it would be if it rained? It would have been so nasty.
I have to stay at the house.
Oh, don't worry. The whole state would be shut down. People in Buffalo and people in New England travel through 15 feet of snow both ways uphill. One snowflake falls in Anderson, and we all go to buy bread and milk. All right, so we've done x minus x bar. Now what are we going to do? Read the formula. We're going to what? Square it. Or square it, depending on where you're from. So here is x minus x bar, quantity squared. So basically what that does is it makes everything what? Positive. And copy that down. Now what? Quit. The best thing to do is quit. Add them all up, because that's what that BAE right there means. That funky looking sigma, that's a Greek letter for capital sigma, okay? That means add them all up. So we need a total. So I'm going to go over here, and I'm going to write down that 376, because that's our numerator. Now I'm going to do the denominator for y'all, because y'all been working so hard. 7. Okay. Now take your handy dandy calculator and divide 376 by 7. Dang old 5. 26 be what? 4. Dang old 57 or 56. I don't know. 57. If it's 4.7, what does it come out to be? Oh my God.
53.71.
I'm sorry, what?
53.71.
53.71. Sorry about that. I suck. So we take it up to our variance key. And we make sure that I know what I'm doing. Right here, we say equals this number divided by what? 7. It's a miracle. Now, the question I always get about this time is I always get, well, how do we know what to round? Well, the best thing to do is carry it to 5 or 6 digits and round when? At the very end, right before you type in your answer. No sneezing in class either. At 3 sneezes, 3 yawns, I throw you out. 3 coughs, I throw you out. That's a joke. All right, now what? What is the relationship between the variance and the standard deviation?
Variance and the standard deviation squared.
Exactly. The square root. Write this down, because you're going to need it on a standardized test, because they always ask this question. Find the variance, find the square root, find the standard deviation, and they only give you one number. All right? If they give you the variance, then you take the square root of the variance to get the standard deviation. Okay? If they give you the standard deviation, what are you supposed to do to get the variance? You square it. You raise it to the second power. Remember, the variance is always larger than the what? Standard deviation. We're going to talk about that, because if I asked you what the standard deviation is, this is what y'all will say. Class, what is the standard deviation? And you'll say, hold on a second. It's equal to this number. I hate it when it does that. Hold on a second. Might as well just quit. Equals, what is that? G-H-I what? Is it I-8? I-7, thank you. I-7 divided by, or raised to the 0.5 power. If I asked you what standard deviation is, you would say 7.32. And I say, what is standard deviation? And you say 7.32. And I say, what is a standard deviation? And you'll keep saying what? 7.32, because you don't know what the standard deviation is. Anybody know what the standard deviation is? It's the spread. Write that down. It's the spread. What if I have a big number on the spread? That means your data is not tight. If I have a very small number on the spread, that means the data is tight. Anybody ever? Well, no, just forget it. I was going to give you an example, but half of you wouldn't know what I was talking about. All right, bicycles. Everybody in here hopefully has had a bicycle in their life. All right. What happens when the chain gets worn out? It gets what?
Loose.
It gets loose. And what eventually does it happen? What happens when the chain gets loose? It falls off. And then you have to put it back on. All right? The whole point is, when you have loose data, the spread is going to be wide. When you have a loose chain, it eventually is going to what? Come off. All right? When you have tight data, when the data is very close, the spread is loose. I mean, the spread is tighter, and if the spread is tighter, that means your data is tight. That means you have good data. Good data, tight. Write that down. Good data, tight. Loose data, or bad data, loose. Now, how do you tell this? Anybody? Can anybody tell me how you can tell, besides your besides your standard deviation, how can you tell that your data is tight? Anybody want to take a stab at it? I'm going to take my handy dandy highlighter. This is called tendency of center. Write that down. Tendency of center. Somebody tell me what that means. In statistics, the most important area is the center. Write that down. In statistics, capital S, meaning in the field of statistics, the most important area is what? Center. Tendencies of center. I'm going to take my handy dandy highlighter and I'm going to highlight that one. I'm going to highlight that one. And I'm going to highlight what? That one. That means you need to highlight those three numbers. What do those three numbers tell us? They're about what? They're about the same. If they're about the same, or they're in the same area, that means your data is tight. If you've got three numbers right there that are tight, then what is your standard deviation going to be? It's going to be relatively small, which means the spread is what? Small. That means your data is what? Tight. Good. So I'm going to highlight this one. Dang old, whatever that is. Aqua, maybe. Now, let's say that you had a bad day. And let's say that you made a 23 on one test. What just happened to my center? It's all over what? It's all over the place. All over the place, not good. That's called variance. Variance is basically, let me go into this because a lot of you don't know. Okay? And I mean that in sincerity because a lot of people come out of probability and statistics in high school and I ask them what the average is and they tell me, you add them all up and divide by, and that's all they tell me. They don't tell me what it is. All right? So what is the variance? I meant not the variance. What is the mean? Can somebody give me the definition of mean without using numbers? Oh, come on. It's the average. Good. It's the average. And what is the average? You add them all up and divide by the number, okay? What's the average? Give me the definition of the average.
Is it the mathematical selective representation of the data?
That's pretty good, but that's not it.
The mathematical center of the data set?
So what?
The math. That's what
I think you said the mathematical center of the data set. That's close. That's still not the definition I want. There's a definition of the mean, or the X bar, or the average, whatever you call it. And a lot of people have no clue what it is. I'm waiting for a good guess of a definition. Huh?
Math theory?
No. She'd give you her pinky up in the air definition. I'm looking for a layman's definition. That's what I teach. All right, I'm gonna give you a picture of a bar graph or a histogram. And let's say this is 2, 4, 6, 8, and 10. Everybody with me? And this is group A, B, C, D, and E. And that's just groups. It could be anything. Okay, I don't care. Class, category, whatever. I don't care. All right. The whole point is, if I give you 2 here, and I give you 6 here, and I give you 2 here, and I give you 8 here. Okay, hold on. I gotta do some calculating here. I think that's gonna be close. Yeah, I think it's gonna be close. And a 4 here. All right. Let's say that I take this guy right here and I cut it off. And I cut that off, that 2 right there, and I flip it over and put it right here. Everybody with me? Everybody with me? So I'm gonna just kind of take my handy dandy there. I just took that off and I put it right here. And then I take the 4 off of this one. Okay, I messed up. Let me put it right here. I don't have anything there. And I take the 4 off of this one and I put it right here. Some of y'all might call this redistribution. Okay? And I erase these 2 right here. Okay, what have I just done?
Yeah, but set average.
Uniform distribution. Uniform distribution is what the average is. The average is, okay, the average, the mean. What is the definition of, it's the number that represents uniform distribution. What is the only thing that's uniform in our universe? What is the only thing we cannot control? Time. So whenever you're talking about a uniform distribution, you're talking about a box that looks like time. So 4 would represent the uniform distribution in this case. 4 would be our what? Average. Okay? That's the definition of the average. It's the number that represents uniform distribution. What is uniform distribution? It's the opposite of variance. Variance would be what we had. What did we have? We had this right here. Something like that. Didn't we have that? That's variance. Variance. The more the spread, the more the variance. The less the spread, the more uniformity. Okay? So that's the difference. And if you walk out of this class with nothing else, let's say you go brain dead the rest of the semester. All right? If you walk out of this class with knowing that the definition of the mean is the number that represents uniform distribution, that means a lot because you're understanding why you're finding the mean. You want to find that number that represents uniform distribution. Because uniform distribution, as you said, I think you said a while ago, is the what? The center. And everything in statistics revolves around the what? The center. So if you take that number, let's go back to our handy dandy spreadsheet, and you take this number and you make this a, let's go with, leave this a 23 and make this 107. What does that do to the numbers? Look at the standard deviation and look at the green. Look at the highlighted green and watch the standard deviation. So I'm going to change this to a 96. Watch. Okay, the standard deviation is still all over the place, but what did it do? It came what? It came down. Now, the number, the center is all over the place, so we're going to go up here and we're going to change this to 84. Now watch. Somebody said, whoa, they actually saw it. That's the difference between regurgitation and learning. You're learning what the mathematics do, whatever, okay? You're learning it. I'm not giving you the information and you're simply what? Regurgitating it. I want you to learn it, okay? And you're learning it. You're finding out that if I got bad data, if I got a 23 in there because I was hungover one morning, then that's going to affect what? It's going to affect the spread, and it's going to affect the middle. So now I have no middle. My middle is 82, 91, and 60. Those three numbers right there say you got some screwed up data somewhere. You got an outlier somewhere. Now let's talk about that. How do you use the handy dandy standard deviation? Somebody tell me how you use it. Now you use it as an indicator. That's what the number is, an indicator. Now how do you use it?
To determine if a data point is an outlier.
Yeah, but tell me how you do that. How do you do it?
Is it the mean plus or minus the standard deviation?
There you go. Good job. You remembered something. Good. You remembered out of your whatever class. Okay. So I'm going to take my handy dandy curve. All right, that's one yawn. I saw it. I keep up with these yawns. Oh my gosh. I suck. Damn Russians. There we go. I take my handy dandy curve. Now, somebody look it up in your book. It's called the Empirical Rule. Look it up. It is a test question. It's 4 or 5 test questions. Empirical, I can't spell. Empirical. There we go. Empirical Rule. Somebody look it up and tell me what page it's on. Somebody's got a book. If you don't worry about it. Look it up in the index. Empirical Rule. It's very, very, very important for your test. You got to learn it. Okay, the empirical rule states the empirical rule states 34% falls here, 34% falls here, 13.5 falls here, 13.5 falls here, and 2.5 or 2 point, now this is where it gets different between books, 0.3 here, 2.2 and 0.3. Some books have 2.3 and then 0.2. Okay, we're not really concerned about that because we're only talking about 0.1%, which is not much, okay? But make sure you know what your book says. Somebody have a book, somebody know what book page number it's on, nobody's got a book, okay. Just find it in the book. All right, the empirical rule states this. The mean is right here. In our case, what's our mean? 23.6. I'm going to say 24 because I ain't going to do the decimals. You do the decimals in your homework and your test. Use your calculator to add on the right, subtract on the left. What do we do on the number line since you were in the 2nd grade? What do you do to the right of 0? Do you add or do you subtract? You add. What do you do to the left of 0? Okay, so nothing has changed. Don't go stupid on me and say, I don't know what I'm supposed to do. All right. What's the standard? I'm sorry. The mean is what? 84, 83. Sorry, I messed up. I was looking at the wrong number. X is equal to 83. Now take your calculators out, and I want you to add 83 plus 24. What do you get? 107? Then add another 24. What do you get? 131? Then add another 24. 155? Now I suck at subtracting, so you're going to have to help me. All right, so what is 83 minus 24?
59.
Say again?
59.
And 59 minus 24? 35. And 35 minus 24? I'm sorry, I heard a mumble.
11.
11. Now what does this mean? Well, the empirical rule states that between the 2 standard deviations is 95% of the population. So, between, and I'll take my handy dandy highlighter, and we'll color this light green. Between 2 standard deviations, 1, 2, 1, 2, 95% of the population is going to fall between 2 standard deviations. This is what we call, as my daughter used to call it when she was little, now she's in college, normal. Okay, she won't say normal now, but write that down, that's normal. Or not unusual. Now some of these books and some of these tests and some of these standardized tests, they're going to say, please tell me what is not unusual. And you're going to go, not unusual, what does that mean? Normal. They won't say normal, they say not unusual. So make sure you make a distinction in your notes. Normal equals not unusual. So somebody tells me what falls outside of normal. Unusual. So what is unusual? Well, we're going to take our handy dandy highlighter and we're going to color it magenta. And this is what we call unusual. That's unusual. So I'm going to take my handy dandy, I'm going to put normal. I've been doing that ever since my daughter said normal, and that's been like 19, I don't know, whenever that was. She'll be 21 in March, so it's been like 16 years I've been saying normal. So this is unusual. So what's outside unusual? That's your dang old 6'5" second graders. Or your 1800 SATers. Your Michael Jordans. Your Peyton Mannings. That guy up in New England, what's his name? Brady. I mean, I don't care too much. NFL will go to hell for all I care, but he's a great quarterback. Okay? What's his name? Tom Brady? Okay? No, he's not. No, you're being a redneck. Don't be a redneck. You can't, man, is going for his 10th, daggum Super Bowl. You can't say he sucks. You can't. You might say you don't like him, but he don't suck.
He's still in the play game, no doubt.
Whatever. You being a redneck. That's redneck disorder. Don't have redneck disorder. Okay? All right. Anyway, you can't dispute. Now, you may not agree, Tiger Woods, he had a bad little slump, okay? But he's still one of the greatest, okay? Outliers. Outliers are those 6-foot second graders, okay? The 1850 SATers. Is SAT, they even take that anymore?
Yeah.
Or is it the ACT?
Both.
Both, okay? What's the highest you can make on ACT?
32.
Okay, freaking 35, all right? Somebody makes a 35 on it, okay? That's an outlier, even though you can't make it. The whole point is, there are some instances, you're going to find out in college. I don't care if you're in thermodynamics. I was in thermodynamics as a second semester junior as civil engineering, okay? Thermodynamics, one of the most difficult courses I think I've ever taken. And there's a kid that sat in the front, never has taken it before, making hundreds. Okay? Why? Got a photographic memory? Maybe. Is he that smart? No, probably photographic memory, because most of thermodynamics, the first couple of tests, is nothing but definitions. Okay? So I'm sitting back there beating my head up against the wall, on the back row, of course, and he, up here, walks out 30 minutes before class is over. Y'all have had that happen before, haven't you? You will. In college, you will, because you can leave after the test over, and you're going to be sitting there on number 2, and somebody's going to get up and walk out. Now, there's 2 possibilities. They gave up and put their name on it, turned it in, that happens, or they're the 1800 SAT, okay, that has a photographic memory, okay? Yes, those are your outliers. So the outliers are outside how many definitions? Standard deviations. 3, Hubert. That's right, class. So you need to write that down, because that is going to play effect. That is going to be an effect later on. That's your outliers. Make sure you know the empirical rule. Make sure you know how to set up that curve based on the mean and the what? Standard deviation. Because we're going to be doing that mean and standard deviation to the right and to the left throughout this semester. Okay? You're going to be drawing curves throughout this whole semester. So now, that's pretty much 3.1, 3.2, and 3.3. Of course, they draw it out. Oh gosh, they draw it out. They take 10 pages to show you how to find the range. Okay, but that's what you need to know. Now, most of y'all probably know it. Most of y'all probably depend on your calculator, which I don't want you to. I want you to know how to do this by hand, because if you do it with a calculator, you're not understanding what the numbers are doing. You're just looking at it and regurgitating. So make sure you understand what these 3 numbers tell you. Sorry, this thing's going crazy. The Russians. And this one, what this one tells you. Somehow I switched from highlighter to red pen without even doing it, so I'm special. Why didn't I circle the variance? Variance doesn't tell as much as standard deviation. Okay, so it's not that important. You ask that on homework questions, yes. So that's why I include it on this spreadsheet, so that way you go through this whole thing. Now, another thing I want to tell you, hold on a minute, let me see what time it is, because some of y'all are going to start convulsing. What time is it? It's 9:18, so yeah, some of y'all are going to start convulsing pretty soon. You're doing your zipper convulsions and your book bag convulsions and whatever convulsions y'all do. So I would suggest y'all find some medication for that. You know, some, what's it called, Prozac or something? Some of y'all drug heads know what I'm talking about. Yeah, there you go. Yeah, you need Adderall. You can sit through a 3-hour movie, but you can't sit through a 1-hour class. Yeah, I went through that with my daughter. I told her she was full of it. Okay. Put your date down here. Put your name, please, or put the check. And pass it around. Yeah, I didn't tell y'all to get ready. I didn't say, what are y'all doing? Y'all having convulsions. I just said I was going to pass it around so y'all won't have convulsions. And there you go. Start having convulsions. Okay, now you can put your stuff up. All right, who's got questions on this? Now, this is what I suggest you do. With every single problem you're given a data set, we're going to go over this for the next 2 or 3 days. Every single problem you get with a data set, whether it's 5 questions or 5 numbers or whether it's 15 numbers, should you do everything on here for practice? Yes. Now, if you have LAD, is everybody listening? I told you put stuff up. I didn't say you could have a conversation while I was talking. Okay? There's going to be LAD or okay, it just says this. It just says the mean and standard deviation, so that's all I'm going to do. Go ahead. Then when I get to the test and you get to the test, don't cry when you what? Get it wrong. Okay, now questions. Yes, sir.
So an outlier is anything
Past the third standard deviation. So if I scored 157, that would be an outlier. If I scored a 10, that would be an outlier.
So even though something's unusual and it's daily,
Unusual is the first stage, then outlier.
but you can still use unusual data.
Yes.
Excuse it.
Yes, unusual, but like I say, when you get out here, in other words, when I was in physics at Clemson, we had to build a car out of a mousetrap. Okay, and all we could do is put wheels on it, but we had to generate the power through the spring on the mousetrap. We had to run it. We had to run it a trial times, but we ran it 15 times and took the 10 times that it didn't run off the road and didn't break or whatever. So we took 10 out of 15. Why did we take 10 out of 15? Because there was 4 or 5 in there that was out here. So when you're using data, if you do 300 surveys, or if you need 300 surveys, do 350 because there's going to be 50 or 25. It's not going to fill out anything. See what I'm saying? So you got to use your data. That's how you use it. Who's got a question? All right, so you need to be working on now 3.1, 3.2, 3.3. Start sending those questions in. Now, we got to do frequency distribution. We got to do the mean and standard deviation of frequency distribution, which some of you have never seen before. And if you have, you've been told to do it on your calculator. And that doesn't do anything because you don't know what it means. All right, y'all get out of here and have a good day. Glad y'all got to see me today.
I gotta see you.
Yeah. Miss Sexton, how is your grandmother and grandfather doing? I think your grandfather was in the hospital a couple of weeks ago, wasn't he?
He had surgery a couple months ago. My grandma just broke her foot before Christmas.
And you gotta tell Selma to lay off that sauce. You gotta tell her to lay off.
Yeah, she needs to. She's got a bad knee on one leg and then a broken foot on the other, so she can't walk at all.